So today we are starting with the lecture 2, which I called Python Fundamentals. And I'm going to go in between this is always, I go in between, so now I have to figure out how to click on that thing up there to swap this place, no? Is this okay? So that I don't have something got messed up. Well, I rebooted my machine and now I can't click on the swap displays because I see this. So now, just a second. Maybe here? No? No. Okay, I'll leave it as this. It's not a big deal because we will go to programming anyway. So Python is one of the programming languages. There are many, and it's an evolving landscape. So you can expect in your lifetime to use at least 2 or 3 as they change. What is good about Python is that it's free and open source and pretty much exists on any operating system. It's actually pretty, what I call, close to the operating system, and is used to actually just move things around, especially in larger systems. So there's like a lot of sort of underlining operating systems tasks that are often executed in Python. However, it has a module for pretty much anything else you want to do. And we are, so this is what I mean, modular. So you can kind of like add functionality to it relatively easily. We will actually learn how to create functions that you can go and reuse, and you can always package whatever it is that you have developed into a module that you just send to someone to use. So that's this modularity and ability to extend. And it can work on a single computer, which is what we are going to use here, as well as in high-performance computing. When I say high-performance computing, there is something at play that is typically using multiple either computers or video cards or something of that sort at the same time. So that's next level of programming that we cannot touch in an introductory course, but you should be aware of it. For the most part, you probably know that your computer is a multi-core. So maybe it's a dual core, maybe it's a quad core. Right? That means that there's actually 2 or 4 working CPUs with it. Okay? And this course used to be in MATLAB, now it's switched to Python. Technically, the choice of the programming environment for the introductory type of course doesn't really matter. The concepts matter because you will learn another language later on. We switched it to Python because Python is much more used right now, and quite frankly, if you have Python on your CV, that can be a difference between getting an interview or not. So in that sense, there's a lot of impetus to use Python. Now, the name is adapted from 70s series, Monty Python. And there is Python 2 and Python 3. We will focus on using Python 3, though there is a lot of code and courses online that are in Python 2 and Python 3. There are small syntax differences. However, Python 2 is outgoing. So within probably 5 to 10 years, there will be very little development. So that's why kind of, right now it's the transition time between the two. And there's, again, numerous online courses. If you can feel free to search and extend. I have suggested there's a textbook that is in your syllabus that is actually downloadable through UT Library. So there's no need to purchase any textbooks in this course. That one is actually done by somebody in math department here at UT, and the book in itself is available as an e-material in library. So feel free to augment But feel free also just to do a Google search on any topic that you need more understanding on, because there's plenty of materials. Code Academy course is one of the standards. It's actually very good. The only thing is that it currently uses Python 2 unless something changed in the past 2 months or so when I checked last time.
And what's the title of the book?
It's in your syllabus. Yeah. So Python is probably already, or it was before you did Anaconda installation, installed on your computer. I personally, before I installed it, you could just type in Python, and you're gonna sort of get a little shell where you can start typing in commands. And that's the whole point. So there's a certain way to type in those commands so that the computer can understand. This is what we're going to learn in this lecture. But there's also this interactive environment. So there is Python listening for your commands and waiting to interpret them and execute them. Otherwise, if you're not in the correct environment, that cannot be done. So that's essentially what means having Python installed. That's basically having this interpreter installed that can interpret commands that you're typing in. Okay? Now we will actually use something a little more, so you can technically either in command line on your Windows computer or your command window, or a terminal on any kind of Mac computer, you can just type in Python and start using it. That's not very pretty or user-friendly. It's just like a very blank, bland text, and you can type in plain text, no nice windows to click on. Okay? So we will actually use something that is on top of that makes it much more user-friendly experience. But quite frankly, that's how computing used to be done, and only that way, through these like little terminal windows that have only text ability and nothing else. So nowadays we have much better environments. So this Anaconda, so I'm going to skip this slide because you installed it already. It comes in with a number of things in there. So if you start Anaconda Navigator, which I can actually go and start it myself. Well, actually, I think I did. There we go. So these are this. And you can install much more to it, but these are some of the basic tools. The ones that we're going to focus on are Spider, okay, which is a nice little development environment. And another one is Jupyter Notebook that actually channels all of the communication between you and any kind of Python interpreter through a web browser. And creates actually a file, and I actually find it very nice for teaching. And you, I think, will find it very also nice for creating homework and ultimately just printing it out. So basically, kind of your report for homework will be done. You just kind of print it into the file and you're done. So that's kind of nice. So between those two environments, that's what we're gonna use most of the time. If you think you're in Spider, but somehow things are kind of looking different, you probably clicked on Jupyter Lab. so know that those two are actually similar environments that can be used in this very same way, but they look visually different. So if you get confused, like what's happened to my Spider, you probably clicked on that first icon. Okay. And then there's a couple of other consoles that we're going to not use in this course, so I'm not going to bother explaining them. So just to set the expectations right, you're not going to be an expert after a semester of code. That is a skill that is developed over a longer time, and it's the best developed when you're motivated to actually to do something. So we're going to go over the fundamentals of how to program, and then we will use that skill to actually solve certain numerical problems. Selection of them in this course. But then you will also build on top of that. So Professor De Carlo might ask you to do something in thermodynamics. Professor Haidari before us might ask you to do something in geostatistics, or Professor Perch if he's teaching the course, and so forth. So there's like other courses, your reservoir simulation might be based on a business law. So your other core courses will build on top of that. And it's something that you continue to develop. And you kind of develop as much as you need, really. So just understand that that's just like in anything else, you kind of have to be fit to get going. Right? So in order to do programming well, you kind of have to keep doing it. You can't just wake up and start. Right? So to give you an example, I used to develop a whole lot of code in C. But that was when I was kind of research scientist was my job. So I did it full time. I mean, I was writing papers and writing code in between. Now I'm much more teaching, directing students and so forth. So if I actually now go even to my own code that is quite large, I look at it and I need a moment to actually get going. And if I start just typing code, it's like a language skill that you kind of didn't use over time. I'm going to probably start typing either Python or MATLAB, because that's what I've been mostly using recently. I have another research project that I'm doing in Python, so I'm kind of more into Python right now than I am in that C. So again, it's a skill that you have to constantly use and develop. So don't get frustrated, just work with that. And again, as I said, computer is very picky. When you talk to another human, and I continue, English is my second language, and I continue to do mistakes. But for most of the time, people understand me. And I make a mistake, and we just move on in human communication. Computer doesn't move on. Okay? It's like, you made a mistake on line 3. So you gotta go and fix that mistake, and computer doesn't want to move on until you fix that mistake. Or worse, misunderstands something completely and does what you don't want it to do. Okay? So be aware of those and don't get frustrated. So we're gonna work introduce variables and arrays. How do I actually store things into something that I can work with in a program? Then we're gonna move on to matrix and vector operations, because vectors and matrices are our way to actually store data. And then work with some, introduce some built-in functions that can just like get us going. So your first homework is to do everything by hand. Okay? And this week we will learn how to do it in Python without doing it by hand. Okay? So beware of that. So I expect you not to make mistakes in your first homework, because you have actually a tool to check on your work. So if it's multiplying matrices, you can check what the result is with the computer. So do that. And then input and output. How do we communicate data to the program, and how do we present that data out of the program, including visual representation, which is plotting. So let's get going. So our objective is to basically figure out how to base all of your homework one, how to work with matrices, how to get them to multiply, print, get into the memory. We want to just figure out how to translate that to the computer in this lecture, and then also learn some of the tools that already exist for efficient manipulation of that data. So first concept that we're going to introduce is the variable. Variable or variables, we are always going to use multiple, are ways to basically reserve a chunk of memory. Okay? And you don't think of your memory as a physical thing. It's typically hidden within your computer. But everything that you read and write on your computer, you have to store somewhere. So that has to have a certain place, and computer has to know where to go to get it. So we typically reserve a memory location, so that the location has an address, just like your house or your apartment has an address, so that post or any kind of mail can find you, or post office person. So post office person, that's kind of outdated these days. It's like mostly Amazon deliveries. Anyway, so they have to know where to people living in there, same things happen to variables. So I have to have certain space to put my array in. So we mentioned that our vectors in engineering are typically, I don't know, a Verilog, let's say resistivity Verilog, okay, that has 5,000 entries. I have to find a physical space on my computer to put those 5,000 entries. And then after that, I have to be able to get to them. Okay? So whenever I want and get what is my resistivity at 2,000 feet, I should be able to get that out. So that's this ability. Now, different type of data takes different types of space. So we also have to have certain data type associated with it. And we're going to spend a little more time in our upcoming lecture on the types. But basically, how I store integer number in my computer memory versus a real number, which we're going to refer to as float for historical reasons in computer science. Those are floating point numbers, because in scientific notation, that point can kind of move depending on the exponent. So basically, you have to tell computer what it is that you're storing. Maybe it's a number, different types of numbers. Maybe it's text. Okay? And text is actually stored as numbers as well, but there's an interpreting layer that says, oh, number 255 is, I'm going to guess now, Z. Right? So basically, there's a little table that translates numbers to characters. And that also allows your computer to switch between different types of characters and different types of languages. So if you have installed Chinese or Korean on your computer, those characters look very different in how they're interpreted. If you're from Croatia, so that actually the keyboard doesn't look too much different, but it has 5 extra different letters, and that's enough to move things around and make me really frustrated when I get to a computer at home, okay? Because I just don't know where the letters are, or make some mistakes. So again, there's an interpreting layer between the numbers and text, and how do we encode text. So again, computer has to know what it is that it's storing, and when it has certain memory, it has to know how to approach that memory, where to find it, and how much of it to take, and how to interpret it. There's quite a bit involved in how we actually store data. So that's why it's important to specify data types. Some of it will actually be done nicely for us on the fly, but you do have to understand that there is a data type underlining all of the variables. Okay? So one thing that we're going to do when we open is everything is interpreted as a command, unless I actually put a little sign for it to ignore. And that's just the text in the text file that has the commands for us, for humans to refer to. Okay? So be aware of that. So we're gonna, and this lecture will be, I will, as we go, upload also these Python text files. So some of them are Python, and some of them are IPYNB, which is IPython Notebook. That's the web browser kind. So these are 2 different files that support, and we're gonna get to the differences as we go along. But again, I want you to work along with me as we are typing things, but if you don't get to something, rest assured that it's going to be posted, and it's also part of this video. So don't get frustrated if you're lagging a little behind. Take your time that it takes to work to it. As long as you actually kind of do something in class and get your little wheels going, that's beneficial. The worst thing is just to sit and kind of be passively sitting and getting information. So as long as you're working on something, you're going to be fine. Everything else is available either as video or these files. Okay, so let's actually get going with some very simple stuff. And I did post this file on Canvas. It's in files, so you can look at the lecture out there. So I'm going to start Spider. So we're first going to introduce Spider as an environment.
And for some reason, all of these programming environments are into animals, either snakes or spiders or whatever, which I don't like necessarily to think about, but oh well. I'm not gonna update anything right now. So there are two ways to do things. This is so let's just orient ourselves. Okay? And I'm gonna kill a number of these. Oh, now I killed everything. Oh, never mind. So this is just I'm gonna restart it so that I get it again. So there are two things. You can just work with command line and just type things as you go. In that case, some of it is stored in what's called history, and you can go back to see what you typed in. But that history has certain limit. I think it's a few thousand lines or so. And then it just moves up. So, 2 months from now, you're going to move up so much that it's not going to be available. So you might want to just simply store it in a file. Okay? So we're going to do both. Now it's not launching. Okay. Restarting Spider again. And then again, this little number 3 refers that it's working with Python 3. Okay. So you're going to have on the left side here, those are actually files, okay, that you can just execute with a click. So you put a collection of commands and they will execute one after another. You can immediately in this file see some of the comments. They're kind of in this light gray color. That's not going to execute. That's just text for you to read or for you and me to read. What executes is these statements such as print and so forth. You can also simply type things in. So I'm going to actually start here and just typing things in. So that's this interactive mode. Okay? But then ultimately you might just want to save things in the file as you go. So let's just start typing. And so let's define a variable. If I say, hey, a is equal to 3. Okay? Now let me get this down a little. There's also a variable explorer right here. Is everybody located it? That actually tells me, hey, you define a variable a, which is an integer. It has only one integer in there, size is 1, and its value is 3. So that's kind of really neat. And this is this environment nicety. Otherwise, you would have to find other ways to figure out that you actually have a variable defined. Now, if I wanted to get back to what is that variable, I can say print a. Okay? And then it's going to tell me, hey, it's 3.
Do you hit enter in order to get the IN?
Yes. So after IN, you click enter to execute. You can also, so this is actually now a stored value, okay, that I can work with. I don't have to store values. I can simply use this as a calculator. 2 plus 3. Answer is 5. Okay? Or 2, this is how you do to the power of 3. The answer is 8. Okay? So this works as a calculator, but typically you want to store things in a value, in a variable. Now, what happens if I try to define b that is not just an integer, but it actually has this floating point, 7.2, okay? B shows up there, and you can see that b is actually interpreted immediately as a floating point. So this thing is smart, or it appears smart. It's programmed behind to actually go and gauge what it is that you typed in. And then it stores it accordingly. That's the beauty of Python. MATLAB does the same. C doesn't. In C, you have to, initially at the beginning of your program, you have to tell it, hey,
give me integer A and give me float B. And then within the function, so you have to declare it first. This is what it's coming, and then you assign values to it. And you also have to do a processing step. You can't just do this on the fly business, interpretation on the fly. You actually have to process it before you execute it. But because of that, it's faster. So this is nicety, but it comes at a cost. And we're going to compare speed a little later when we actually get some knowledge, but I'm going to exemplify to you what it means to be faster. So for certain tasks, you might want to use this nice environment to develop and then figure out a way to speed it up. Okay, so this is just A. And now I can work with these things. I can just say print A plus B. Or print A divided by B. Or print A to the exponent of B. So whatever arithmetic you'd like to do, you can. And I have introduced here, without saying, a first built-in command. Which one? Or built-in function. So you're probably either on file explorer or help, so click on variable explorer. See variable explorer, click on that. And then you might want to move it up a little so that you get the space. So these things, if you fly over them with the mouse, it's going to show you that you can move it up and down. So you organize your space, see, to fit your screen well. So print is a command. When I type in print, it obviously has certain what we call syntax. So I have to give it whatever it is that I want it to print in parentheses. And this is not the only way to call that. So there's actually multiple ways, but I do have to stay within the rules or within the syntax. So print, there is a function somewhere that actually tells, or a file that tells Python what to do when I type in print. And that's essentially a built-in function that already exists. And we're going to create some of our own that we design. So it doesn't have to be just, so these are typically numbers, okay? It doesn't have to be just numbers. I can just say name. My name is Masha. You can type in yours. And note what I told Python, how I told Python that this is text. Name as such, or variable names are already text, okay? So I have to tell Python the difference between actually a variable that stores text, or the text that is stored inside a variable, and a variable name. So I'm going to start with an apostrophe to actually tell it, hey, this is a text, and interpret this as text. Yes?
Does it matter if it's a single or double?
Let's give it a try. Okay, so this is, and you can see that it interpreted it as so-called string. Let's try different.
Get rid of the one.
So in Python it doesn't. In many other languages it might. And then it can get annoying when you get used to one of them. And then you go to the other. Which happens a lot. But Python figured out, okay, there are all these programmers coming from everywhere. Let's just give them either. Fair enough. So what I exemplified right now is many times when you're about to type something and you don't know, try it. Okay? Give it a try. Does it work? You can also go and read about it, but you can also simply try. So the learning is somewhere in between both. Okay? And I can also print those. And if you notice, Python is smart enough to know what to do if I give it an integer, if I give it a string, okay, or if I give it a floating point. In all cases, it prints correctly. So that's this level of interpretation that goes underneath. It knows how to read all of those variables for what they are, and then even though they take different amount of space in the memory. Okay, so this is the simplest way to do, and then here we are using Variable Explorer to see the type of a variable. But if we didn't have this nicety in this environment, what we could do is just say print of type of A, and then it's going to tell you, oh, it's a class integer. You can also say type of A, and then it's just going to say int. So there's a little more information coming if you use print command, but either way you can find out what you have in there. Okay. So those are some simple scalar variables and operations on them. And our type is another function. So we have so far functions print and type. If you wanted for your own use to start either a file or Excel sheet or something and add commands as we introduced them, that could be an effective way to have a very good cheat sheet for your exam at the end. And also as a tab of things that you learned, so you can easily go over the material. You can also change types. So we already figured out, hey, there's this way to interpret, or Python interprets what you typed in. You can also change it. So you can say, hey, create an integer out of 2.3, in which case it's just gonna, this 0.3 will get chopped off. Create an integer of minus 2.8, same thing. Create a floating point number out of integer 5, it's going to be 5.0. So kind of declare what type you want it to be. And the way these rules work and what works and what doesn't is by common sense. Whatever is a common sense to you. Can I figure out an integer out of 2.3? Yeah, you can. We do rounding off in math all the time, right? Or simply chopping off. So basically, whatever makes sense can be done. And if it doesn't make sense, computer will still do something, and then you will have garbage in your memory. Okay? That's how bugs happen. And it might, the worst is then when a computer doesn't tell you that it did something. Okay? Sometimes what's actually nice for printing and so forth, you can also create a string or a text out of a number so that you can print it together with other text nicely. So that's often useful. All right. So again, this is just a reminder on your slides that your basically Variable Explorer lets you inspect what you have. Okay. And one small warning with the variable names. Typically, if it's an operation like a plus, minus, and so forth, it's not a good name, okay? Because then Spider or Python or whatever it is that you use doesn't know how to interpret it. Is it supposed to be operation or is it supposed to be a variable? So pretty much if you type in A minus 6, it's going to try to do operation A minus 6. So don't name a variable that way, or rather it's going to give you trouble if you do. So I would stick to basically basic letters, and then you can add numerals at the end of it. It's not going to get confused if you just add numbers. So Masha 5 is fine for a variable name. That said, Masha 5 physically doesn't need much. You're engineers, so if you do programming and actually names mean something, if it's a radius, don't call it Z, okay? Because that would be misinterpreted as a Z direction or something like that. Call it R or RAD or radius or something that is meaningful so you will be able to physically see what's going on in the program. So think about that. Naming of variables is actually important. Okay. All right. So use meaningful names and kind of stick to numerals and letters. Yeah. So arithmetic, I already introduced arithmetic or operations. A lot of them are common sense, so addition, subtraction, division. There's one that is modulus that gives you remainder during the integer division. Okay, that's the percent. And then multiplication is 5 times 2 is 10. Now, if you want to do integer division, which is also called floor division, so how many integers do I have? Then you do a double slash. N to the power of is double multiplication. So those are the arithmetic operations that you need to use. So let's now switch to something much more extensive, not like a single variable, but I can put multiple numbers in and organize them into array and vectors. So what we need to know about that, first we will learn how to generate some of the matrices just by typing them in. That works really well for the homework you have currently at hand, which is going up to 3 by 3 or maybe 4 by 4 or somewhere in there, so something that is easily typed in manually. If you are patient, you can go up to 20 by 20 when you need to do something like that. But overall, we also want to find out a more efficient way to input data, especially if you have some very large data sets. So let's say that you have a matrix of 1,000 by 1,000, or that resistivity log that I mentioned at the beginning that has 5,000 entries. I'm not going to sit typing things in. Okay? My time is a little more expensive than that, especially in this day and age. So we have to figure out how to basically just import data and read it from a file. So first we have to store data, either in some sort of a file that is, again, in computer memory, and then I have to figure out how to read it. Now, those operations always depend on how it is that you decide to store and what the file is. And files have their rules. So you have to know what is the type of the file. Right now, you already operate with a number of them. Let's say that you have a Word file. Okay? It has an extension, doc or docx, that tells you that it's a Word file. If you try to read it with a PDF interpreter, good luck. Okay. Same thing for PDF. It's a very specific file. If you try to read it with something else, good luck. Your screens and phones are very good at loading images, which are essentially two-dimensional arrays. Again, there are certain formats, .png, .jpeg, and so forth, .tiff, okay, and so forth. Those are all different formats, and if you don't know how to interpret those formats, you're not going to be able to read the data. You're going to actually go through a little bit of struggle there and manually read and write certain data just to see what the pain is when you don't know what's in there and when you don't correctly set it up. Okay? So then you can actually, next time the file just opens automatically and reads onto your screen, you can appreciate that just happened automatically. But again, there are rules behind of how you store data, and you have to correctly interpret what is coming at you. And there is also, in addition to reading from files, we also be able to put it in a file so we can send it to someone else to use. And finally, there are certain built-in functions that can just kind of create randomized arrays. So let's say that, hey, I know that in my reservoir I have a sandstone and porosities are give or take between 15 and 25%. Okay? Can I create myself, and I don't have values for that reservoir, but I want to test something with that approximate range. Then I want to actually go and be able to create a 1,000 by 1,000 array of values between 0.15 and 0.25, so I can use it in my reservoir simulation. So there are built-in functions that do that type of definition. So we're going to go over all of those. So for this, we're going to introduce our first module, and that's called NumPy. You right now have NumPy installed. This is actually one of our motivations to use Anaconda, because it packages all of the things that are commonly used by engineers. Now, so we don't need to do anything. However, if there is some module that in future you will want to use, you kind of have to tell Python, hey, go and download it and install it. So just know that, and then you can go. And there's here a little bit of how to install. So you can install it by the command pip install NumPy. But then after that, and this is something that we will consistently have to do, we have to tell Python, even after something is installed, that we intend to use it. And that's again for speed, so not everything is loaded if I'm not going to use it, because that's basic. So basically, you just have to know, and that we're doing with import command. So let's actually just check a couple of these functions here. Okay. So I'm just gonna quickly, for instance, do this dir. Basically, that just lists directory of all of the functions. NP is NumPy, Numerical Python. This is my first bug. I didn't import it. So it basically told me, hey, I have no clue what you're talking about. Name error. Okay. So I'm going to import it and tell Python I'm going to use it. Import NumPy as NP. And now I can repeat my command. And note that if you press up arrow on your computer, it's going to bring up previous things you typed in. You see this? And I can go down, up, down, yes? So up and down. It's really useful so you don't have to retype. So I'm going to go up to my dir. And I can see all the possible commands that exist. I can do also help on it, and then I will get more text that I'm willing to scroll down. These days, all of these things are available online. So frankly, I type it in my favorite search engine to find the answer. Okay? But if for some reason you can't go to the search engine and you are left to your own device and it's not connected online, then know that you can list the functions in here with dir, and you can also call help on them. And again, online, there is numpy.org where there is more information. So we're going to now start manual entry of vectors. So let's define our first array. I'm going to type in here. Now before I should have asked, but the size of the, everybody sees this well? Or do I need to up this font size? Is it good? Okay. So basically, let's define our first array. We already imported NumPy as NP. So now I can actually use some of the commands. In first command, that is actually going to tell you, NumPy, hey, create an array, numerical array, is np.array. So basically, I'm going to say C is np.array. Note that I'm indicating to, I imported NumPy as np. Okay? I could have imported it as Masha if I wanted to. I'm not vain enough to do that. Then I'm actually the opposite of that. I'd like to hide sometimes. So basically, then I would call that Masha.array. However, most of the community has adopted, you can call it whatever you want. Most of the community and most of the code out there uses NP, so we may as well. Okay? So NP tells me, well, okay, there's an array function in this NP collection. So use that one, because another collection, I could have defined my own, then I can be vain and call it Masha, okay? Or Masha NP. Okay? because I wanted to do something else differently, and I could have defined something called array, and that's something I would call Masha NP.array. So it's an array function that exists in both. And this, calling it by last name, if you will, so NP is my last name, the first name, allows me to have multiple definitions of the same thing. Okay? And that could sometimes be useful. So np.array, every time I'm calling a function, whatever it is that I'm giving to the function, I'm going to include close in brackets. And this is going to be array, so I'm going to also give it angular brackets. And let's type in 3 or 4 values up to you. I'm just going to put 20, 21, 1, 5. You can see that this array has appeared up there, and I actually have 4 values. Its size is 4, comma. This is Python's way to tell that there's only one dimension. The other one is empty. So it's really just 4. Size is 4. And it decided to go, for whatever reason, with larger integers. So we're going to go get to this, but there's integer 8, integer 16, integer 32, integer 64, depending on how many bits I'm using to store it. We're going to get to that. So just note that this is one type, this is the largest integer that I could store. All right, now what's nice about this, and that comes with Numerical Python, is then I can now operate on in this entire array. First off, my print command still works with C, just like it did with single variables. So that's very nice of command print. It is kind enough to print the entire thing for me, even though there's 4 elements in there. However, what I also can do is I can do multiplication. Let's do print 2 times C. Every element of C is multiplied by 2. Now I'm using 4. There could have been 4,000. Okay? So that's that multiplication of scalar and vector at work in practice. Now, Python doesn't really do column versus row. It says, look, honey, all of those are one-dimensional arrays. Whether you want to look at them as a column or look at them as an array, I don't care. It's all the one, same thing. Okay? So it's just one dimension, so it doesn't really recognize, you have to force it to recognize it as a matrix. And we're not going to force feed it. Okay. So I can also do something more complex. I can really say, I also can divide by something here, 3.4. And then I can also add 1 to it. And note that here, let me just finish one sentence. Here, I did a mathematical operation on the entire array. And I added a single number to it. Mathematically, that's a travesty. Okay. Math says no, this is dimension 4, this is dimension 1. Computers allow me to do that just to be fast. So it's going to add 1 to all of these. Okay. So linear algebra says no. Applied linear algebra as implemented in Python says sure, you can do that. So we're going to pick up from here and continue with matrices next time around. It's